So hello everyone. In the last session we have completed our chapter current and electricity. Now in this session we are going to start a new chapter that is called as a capacitor. It is also going to be somewhat linked with current and electricity. Whatever the circuit theory we have covered in current and electricity, all the concepts will going to be repeat here. Just only the current is going to be replaced by the charge and everything is going to be the same. All the things will be same exactly. So I'm not going to focus that much circuit theory in this. We will focus on the more important concept that are purely related to the capacitor. And second more thing, if you want to understand that how to solve the circuit theory question related to the capacitor, then you have to see my circuit theory lectures of current and electricity. And in this session this is going to be quite you can say easy chapter. Only there is a one difficulty will come when we deal with the variable capacitors. Generally the student think that this will be slight difficult, where the capacitance value is going to be vary when the dielectric constants is going to be vary. So that may be slight difficulty you will face, but if you are able to do the proper imagination, if you are able to do that as we have done in the resistance while the calculation of resistance, you can also do that also. Other than this, it's a very easy chapter. Everything is known to you. So if you have covered current and electricity, then you are not going to face any problem in this chapter. So let us start a new chapter that is called as capacitor. Okay, that is termed as a capacitor. So this is going to be our new chapter. Basically, what is the discussion in this session? What we are going to discuss in this session, we are going to discuss about the basic things, basic idea that how the capacitors has been built up, why the reason that why we have developed capacitor. First let us talk about that why we need a capacitor. Okay, I'm going from very basic. Okay, so first question is arises, sir, first question is came into the mind that why we need a capacitor, sir, why we need a capacitor, what is the need of a capacitor, why there is a need that we have to build a one capacitor. Okay, that is the first question should come in your mind, because when we are reading something, the first question should come in your mind that why we are reading this thing, why after the plum pudding model we go for the Rutherford model, Thomas model, Joseph Thomson, why these models are developed, there is some reason for this. So similarly here also the first question must be come into your mind, sir, why we need a capacitor, what is the reason for that we need a capacitor. Suppose whenever we suppose this in fan, suppose we have a fan. Okay, I think everyone has seen there is a small cylindrical like this is present in the fan. Okay, that is as a one terminal like this. This is people used to say is as a condenser. It is called as a condenser. Whenever the fan rotates slowly or the speed of the fan reduces, the people say that okay, change the condenser, replace it by the some other condenser. What is basically this condenser is? This condenser nothing but a capacitor. This is a capacitor. Okay, this is a capacitor. This condenser is a capacitor. So what is the basically the use of capacitor? It is in your fan, it is in your electric motor, whatever the devices which require a very large amount of current for its functioning. Basically if you know, generally we have whatever the experiment we do in the lab also, when you go and you will do the experiment, you will find that the current value is very small, like in milliampere, in microampere, you will deal with that much amount of current. You will never deal with 1 ampere, 5 ampere, 6 ampere amount of current, because these currents are very large. It look like they are a small value, but when 1 ampere current will pass through your body, you will feel it how it is. Okay, so that's what I am saying, these current values are not very small. So for suppose there is a fan is there, I want to switch it on. Okay, so what I will do, I will go and just switch, I just on the switch from my board or from the electric board, I will on the switch. For that, see, initially that fan is at rest condition. Okay, it is not moving, it is at rest. For making it on, I have to provide a you can say a bucket of energy to it. Okay, like that I have to provide a bucket of energy to it, means that huge amount of energy I have to provide. This energy means I have to provide a large amount of current to that fan, and this cannot be provided by just a simple switch. It will not provide a 5 ampere 6 ampere amount of current. That cannot be simply provided by just on the switch. No, this energy has to be provided instantly, means it has to be given without any 0.1 microsecond delay. Without any delay, it has to be given just suddenly like this. Okay, just I on the switch, the energy is transferred should like this. So that should be the flow of energy, and this energy I required only for a small duration. It doesn't mean like it does, like try to understand, just I on the switch, as I on the switch, I need the fan need to start the rotation. To start the rotation of the fan, it need a energy of, it basically need a current of 6 ampere 7 ampere like that in starting process. In starting, it doesn't need that 6 ampere throughout its rotation. No, it doesn't need that much amount of current. It need only for starting the rotation, it need a huge amount of current, like an electric motor. There is a every house they have a electric motors. When you switch on, it will pull a water from the ground. So for switching that on, that electric motor, it also required a very huge amount of current, or you can say huge amount of energy, whatever. Okay, huge amount of current is required. We required almost 10 to 12 ampere of current. This amount of current, this huge amount of current, or you can say energy, cannot be provided by just by our home supplies which are coming through the lines, whatever the lines we have. It cannot become. It cannot be generated by that. So what basically for that we have something called as a condenser or capacitor. That's why we have developed capacitor. What capacitor used to do? Capacitor is basically used to store the energy. It used to store the energy in the form of electric field. Okay, it used to store the energy in the form of electric field, and whenever we need this energy, instantly, whenever we need this energy instantly, means I want this energy just at this instant, it will just give me that energy. For example, I switch on the fan, the condenser will directly provide it a current of 6 ampere, and it will start the rotation, then it will stop. It doesn't mean that it will provide this 6 ampere throughout that rotation. No. It will only provide that 6 ampere current or 10 ampere, whatever the requirement, just for that instant to start the rotation. Once the rotation starts, it will automatically rotate. Because starting the motion is difficult. Once the motion starts, it will continue its motion. But starting that motion, that is if you remember class 11th, there we learn about something called inertia of rest. That is the same thing here also. So for bringing the object out of its inertia of rest, we have to provide some initial energy, and that initial energy is provided by only one circuit element, that is called as a capacitor. So what is capacitor? Why we need a capacitor? I hope this question is clear. So what is the reason is? The reason is simply to provide the large amount of energy for a small instant, for a very small instant, that is why we need a capacitor. That is why we need a capacitor. Capacitor, second point, capacitor store this, capacitor store this energy in form of electric field. Capacitor store this energy in the form of electric field. Correct? Capacitor store this energy in the form of electric field. So that is something called as a capacitor. I hope till here everyone is clear what is capacitor. Now, for a capacitor, See, this is about the like basic idea that why we need a capacitor and what is capacitor basically. So capacitor is a device which is used to provide a huge amount of energy for a very small instant, and it will store the energy in the form of electric field. That is basically the idea of capacitor. Okay. Now the thing is that for a capacitor we define a term that is known as capacitance. That is known as capacitance. Now what is basically the capacitance means? That is known as capacitance. Sorry, full stop. Yeah. So what is basically the capacitance mean? 1 minute. Yeah. What is basically the capacitance means? If you try to understand, see, this is basically defined by the scientist. This is not I am defining the capacitance. Capacitance is defined by the scientist, and how they have defined the capacitance, that is very important. They have defined the capacitance as capacitance, that is C, is equal to Q by V. What is the definition they have given? The definition they have given as, this is the formula they have given, but we have to understand the logical meaning of this. The capacitance, we have to take the feel, we have to understand what is physics is saying. Okay, the formula anyone can learn and understand, okay, that is not a problem, but the important thing is that when it comes to solve a good question and difficult question, then you have to understand the feel of the topic. If you have a feel of the topic, then you can automatically solve any difficult question. Maybe it will take 2 days, 3 days, doesn't matter, but you can solve that question. See, so that is the thing, you have to understand the feeling. What is the feeling of this? So what is capacitance? Capacitance means the charge holding capacity. Charge holding capacity of a conductor. Why I am writing conductor here? Because only conductor can hold a charge. Only conductor can hold a charge, obviously. Okay, only conductor can hold a charge on its surface. Why, sir? No, non-conductor also hold the charge, but if you make a contact of non-conductor with another surface, it will lose its charge simply. But the conductor will never lose its charge. It will distribute the charge. And how charge distribution take place, we have explained that thing. So I'm not getting into that detail. That there we have learned about the properties of conductor. For this chapter, the properties of conductor is very important. You have to remember all the properties, then only you will understand. Okay, that is how we define that is charge, that is Q by V, delta V, that is potential difference. So what is a unit? Its unit will be, if I will write what is a unit, you can say coulomb per volt, which is known as a farad, which is a farad. But if you go for solving the question, you will find that generally the units will be given in micro or millifarad or like that, means picofarad, like that. You will never get a unit of farad. Why? Because the farad is a very big unit. Farad is a very big unit, like kilometer. Kilometer is a big unit. Similarly, farad is also a very big unit. You will never get a capacitor of 1 farad, never. It will be either 0.1 microfarad, 0.01 microfarad, 0.001 microfarad, like that. Okay, 10 microfarad, 12 microfarad, 1 picofarad, like that. You will never get a capacitor of 1 farad. That is not possible. Clear? Till here everything is clear. Please note it down, then we will further proceed in our discussion. If everything is clear here. Clear? Okay. Let us see some more points. So what we have learned is, sir, if we have some conductor, suppose, sir, some conductor is there. This is some conductor. Okay, some conductor. I don't know, it can be have any shape, any size, anything else. Suppose it's some conductor. Suppose I given a charge q on it, and if it has a charge q, then it will have a some potential difference delta v. So what is the capacitance for this? We have defined that is q upon delta v. This formula will be, for now you can remember this formula, but remember throughout this chapter this formula is not fixed. It is going to be modified and modified, and at the end of the chapter you will come to know the exact formula. Why I am not telling the exact formula here? Because it will develop by chapter, okay? By means as we go in detail it will be developed. So this is the basically conclusion we got. This is our conclusion. You can say this is our conclusion. Okay sir, nice, we understand this thing. Okay, then what are the other things you can get from here? Wait a minute. Okay sir, I got this, but what is the important thing? The important thing, if you can see from here, that is the C is independent of charge q and v. Means it does not depend upon the potential difference as well as the charge q. It is like resistance. Resistance we know I R is equal to what? I by V, V by I, correct? Is resistance depend upon V or I? No. So obviously here the capacitance also does not depend upon Q and V. Okay, it is a C is a property of the conductor, okay, and C depend on first thing dimension of a conductor, like how the dimension is there. What is the dimension? Correct, dimension of the conductor. That is the first point. Second point, these points are very important, okay, just noted this point. These points are very important points. Clear? Third point, C depend on the medium. Okay, C depend upon the medium. That we will understand in more detail. But for now, I hope you clear that is what is basically the capacitance, how we have defined the capacitance. Till here, I hope everything is clear to you. If you have any doubt till here, you can let me know. Clear? Okay. So if you remember in the electrostatics, we have calculated that a spherical conductor has some energy that is stored from r to infinity. What is the value of that energy? The energy is kq square by 2r, that we have seen. If you have remember in electrostats we have derived that value. Okay, we have derived that value. So we are going to see the capacitance by the spherical conductor. Spherical conductor is a very small derivation we are going to do, and we want to analyze few things. That is why we are going to do this derivation. Okay, capacitance by a spherical conductor. Basically what we have seen, if we have some spherical conductor, we have seen that if we have a spherical conductor and it is a conductor, then the charge q will be present on the surface, and if the radius is r, so it will be uniformly distributed because radius of curvature is same at every point, correct? So this charge is q, and this is suppose center, and the radius is r. So what is the energy stored? What is the energy stored here? It is kq square by 2r that we have seen, and this energy is stored from where to where? This energy is stored from r to infinity. That also we have seen. We have seen all these concepts earlier. What is the potential here? What is the potential on the surface? If you see the potential, we have taken as kq by r. So if I want to write the capacitance for this, what is the capacitance? C is equal to charge is q, What is potential? KQ by R. Okay, so QQ will cancel out. What is 1 by K? 1. See, K is equal to 1 by 4 pi epsilon naught. So what is 1 by K? That is 4 pi epsilon naught into R. So you can see properly from here the capacitance value is 4 pi epsilon naught into R. Clear? So the capacitance by a spherical conductor is 4 pi epsilon naught into R. So what is the thing you can observe from here? The things we can observe from here, observations. What are the observations we can draw? What are the observations we can draw? Observations. See, observations what we have got, the capacitance value we have got is 4 pi epsilon naught into R. Okay. So if the capacitance value is 4 pi epsilon naught into R, first thing we observe that the C is independent of Q and V, correct? That is the first thing. Second thing we have observed that C is depend on, first thing is dimension, that is radius, correct? Dimension, that is radius. Here it is radius, and medium. Why medium? Because epsilon naught is here. Epsilon naught is here, so that is the medium, because we have to consider a vacuum. Third case, if you see the value properly, what is the value of this thing? 4 pi 8.8 into 10 to the power minus 12, correct? Into, what is the radius? Suppose the radius R is some value. Can you see? Now tell me, you do one calculation for, C is equal to 1 farad. What is the radius? Can you tell me what is the radius? Just do this calculation and tell me, for C is equal to 1 farad, what is the radius? If you do this calculation, you can put the value C is equal to 1 farad, and this is 1 upon 9 into 10 to the power 9, correct? Because 1 by 4 pi epsilon naught is 9 into 9, so this will be reversed, into R. So from here, what is the R value you will get? It is 9 into 10 to the power 9 meters. Okay, 9 into 10 to the power 9 meter. This is the radius we are getting. And if you will see this thing properly, analyze this thing properly, this is not a very normal result. You can see this R value, this R is very much greater than radius of Earth. Means what we can understand, if for getting a 1 farad capacitance, just 1 farad, I have to make a conductor whose radius should be greater than the radius of Earth also. Then I can get a 1 farad capacitance. So it is a good capacitor or a bad capacitor? Just you tell me, it is a good capacitor or a bad capacitor? It is a bad capacitor. Also, if you can see properly, we have also seen that this energy, the energy is stored between R to infinity, means it is not bounded. That is not bounded. So if the energy is not bounded, can I use it? Answer is no. If the energy is not bounded, so we can't use it. So obviously this is a very poor capacitor for us. So I hope by doing this analysis you got us some idea like what is the thing exactly. I hope you understand now. I hope you have understand the concept of capacitor, that is what is basically a capacitor, and what type of capacitor we want to make, and what is the idea of making a capacitor. We want the energy to be bounded. Our requirement is what? What is our requirement? We have two requirements. we have two requirements. The first requirement is what? If we will see, our capacitor should fulfill two requirements. The first requirement is that our C should be high. Second requirement is that energy should be bounded. Energy is bounded. And C should be high means our, with this thing, one thing is also included, the dimension should be small. Dimension should be small. See, no one will teach you any platform in so much detail. Okay, I am pointing out each and everything. Should be small. These things you will not find these things in the books. This is not written in a book anyway. Okay, so just try to understand and take the feel of each and everything. Then only you can solve the question. Otherwise, solving a question is not a big thing. Understanding the things properly and applying it, that is a very important thing. So I hope till here everything is clear. That is what we exactly want to do. Okay, what we exactly want to do. Till here everything is clear. Okay. Now after this thing has been done. Now what the scientists start doing? See this problem. Now you got the problem. What is the problem we have got? Now we have to achieve these two things. The scientist has to achieve these two things. Now what are the experiment they start doing? The first experiment they did after this, what is the first experiment they have did? Experiment 1. They have did a one experiment number 1. What the experiment they have did? Let us see. What they have did, they first taken a one conductor. Okay, then they have taken another conductor, same size, everything is same, everything is same, similar conductors. On this conductor it is given a positive charge, correct? And this is a neutral. So as it is a neutral conductor, there will be some negative charge will induce, correct? We know this. And the negative charge will be more on this conductor, correct? And the positive charge here will be less. So now suppose the charge is Q. So now if I want to write the capacitance for this conductor, what will be the capacitance value? Charges remain same, but if you see the potential on this surface V dash is obviously less than the potential, less than this potential, correct? Why, sir? Because there is a one potential is due to this positive charge, there is another potential due to this negative charge now, and this charge is also have some potential, but the distance from this charge is very large, so the potential will be very less. So we can say the overall potential on this conductor is going to be reduced due to this negative charge. So what is happen? V dash is become less than KQ by R. Why? Because of negative induced charge. 1 minute. Okay, due to the negative induced charge, the potential is got reduced. Okay, so we have written. So you can see C dash. This C dash is obviously greater than 4 pi epsilon naught into R, correct? So what we have done in the first observation, what they have done, they have just bring a neutral conductor. This is a neutral conductor, and when they have find that my capacitance value increases without changing the dimension, without changing the medium, the capacitance value is increases. Okay, that is the first observation they have drawn, correct? Now after this observation, they have said, okay, in spite of keeping the neutral conductor, we can do one more thing. Na? What is we can do? They have did a second experiment. What is the second experiment they have did? They have taken the same thing. They have taken a same conductor, and they have again taken a same conductor. And now what they have did? They have given this conductor a positive charge. And they have given a negative charge to this conductor, correct? Now obviously here this potential V dash double dash will be less than V dash, and that is also less than V, correct? because there is a now more dominance of negative charge now. So if I write my C double dash, that will be same charge Q will be given here, and same charge Q minus Q is given here. So this is equal to C double dash, and I can say my C double dash is greater than C dash, that is greater than C. So what we have observed from this experiment, as we are keeping a negative another conductor which is positively charged, in that case I am getting a good capacitor. I am getting a good capacitor or a good capacitance value I am able to obtain. I am able to obtain a very good capacitance value. But the problem here is, again there is a problem with the spherical conductor. What? The energy is not bounded. Here we are able to, in this experiment, what they have concluded, that we are able to increase the capacitance, but the energy is not bounded. So that is a problem. So to solve that problem, to solve this problem of energy bounded, what they have did, they went to the another type of capacitor, that is called as a, so for fulfill this requirement, they went for capacitor. Cap means capacitor. They went for parallel plate. This means parallel, okay, plate capacitor. So from here we invented our new capacitor, that is called as a parallel plate capacitor. So what is parallel plate capacitor? Before going to understand this capacitor, we have to understand all these concepts. Okay, this concept, now we will start our chapter in parallel plate capacitor. Most of the people you have seen, they directly start from a parallel capacitor. They don't tell about this basic, but these basics are very important. Then only you will understand why we have developed a parallel plate capacitor. What is the reason? So that is the reason we went for a parallel plate capacitor. So we have developed a parallel plate capacitor, and remember that in your syllabus there is only one type of capacitor is there, that is parallel plate capacitor. But we will discuss something about spherical capacitor also, as well as cylindrical spherical capacitor we have discussed. We will see also the cylindrical capacitor, and if we get a time we will see some more other types of capacitor. But yeah, this is about the our major portion will be the parallel plate capacitor, and the question will mostly the question will be also only from the parallel plate capacitor only. Okay, so let us start our chapter is going to start. Okay, so basically your level is 0. I have bring it to, basically your level is minus, so I have tried to bring it to 0. Now you are in 0 level. Now we can go to higher level. Now I can start the chapter. Okay, so let us start. So our chapter is now a parallel plate capacitor. So what is parallel plate capacitor? Basically if you have remembered infinite sheet, so basically what we used to do, we used to take out two infinite sheets. Okay, we used to take a two infinite sheets, and let us, the distance between these two sheets is d, the area of this sheet is a, they both are similar. On this sheet we used to give a charge plus q and minus q. So obviously we know that how the charge will distribute. On this side, what is the charge will come? 0, 0, correct, because q1 plus q2 divided by 2. On this surface, q1 minus q2, that will become plus q, and what is the charge on this? This will become minus q. So if you want to calculate electric field here, what is the electric field here? It will be 0. What is the electric field here? You will calculate, it will be again 0. This all things we have done in the previous chapter, electrostats. Okay, so we have plus q here, this plus q charge will come on this surface, correct. I am just erasing this because, okay, okay, and this minus q charge will come on this surface, and there will be electric field like this. You will get a uniform electric field. That is why we learn about, we have discussed lot of things on uniform electric field. Okay, and what is the value of this electric field? If you have remember, what is the value? What is the value of this electric field? Sigma by epsilon naught. The value of electric field is sigma by epsilon naught, where what is sigma? If I ask you what is sigma, sigma is nothing but q by a. So I can say my E electric field is q by a epsilon naught. Correct? So if I want to calculate the capacitance for this all things we know. Now if I want to calculate the capacitance for this, so what is the capacitance value? Capacitance formula is very simple, that is q upon potential difference, or you can say it is basically q between potential difference. It is defined as a potential difference between the plates. Okay, now the question will come, what is that q? So this q, remember this q is the charge on the positive surface of the conductor. What is this q? This q is a charge on the positive surface of the conductor. So what is this q here? Remember, that is what I am saying, this will modify it. So this is the new formula for you. C is the charge on positive plate of a conductor. Basically it is an infinite machine, we were taking conductor only. Okay, okay, so if you put this, what is the potential difference then? See, potential difference is what? If you have remember my thing, that is E dot D, correct? Electric field is potential difference, so E dot D. What is E? E is q by a epsilon naught into D, correct? What is my capacitance will become q divided by potential difference, that is q d a epsilon naught. So if you cancel out, you will get my capacitance is a into epsilon naught divided by d. Okay, a into epsilon naught divided by d. So this is the capacitance of a parallel plate capacitor. What is the capacitance of a parallel plate capacitor? We got that capacitance is equal to epsilon naught a divided by d. What is a? A is the area of the plate and d is the distance between the two plates. A is the area of the plate and d is the distance between the two plates. Okay, that is how we have defined the capacitance of a two parallel plate capacitor. If I ask you a simple question, suppose I give you like this, suppose this distance is c, and suppose this means the a, or you can say basically it is something like this. Okay, like it's a parallel plate. Suppose this distance is a and this distance, this length is b, and I want to calculate what is the capacitance for this. So can you tell me? Suppose this is plus sigma, this is minus sigma. Another way of writing. Similarly, if I suppose if I take a two circular surface and the distance between them is d, and suppose the radius is r, then what? And suppose this is plus sigma, this is minus sigma, then what is the capacitance? I hope you can write these values. So what is the capacitance for this? Simple, C is equal to epsilon naught. What is area? A into B divided by what is distance? C. Similarly here, what is the capacitance? Epsilon naught into area. What is the area of this? That is, what is the area? Pi r square divided by what is the distance? That is d. Correct? So that is the how we can write the capacitance for this. I hope it is clear. Note it down. Clear? Any doubt till here? Okay. So this is the basic concept we understand about the parallel plate capacitor. Clear? So this I hope you can solve this type of example. Okay. I'm not going to waste my time on this type of things. We will try to understand the good questions and good concepts. Now the next concept is that, as we have seen here, that in this spherical conductor the energy is stored, okay, but how much energy is stored? Kq square by 2r. Let us see how much energy is stored in this parallel plate capacitor also. So the energy stored in parallel plate capacitor, like how much energy is going to be stored in this. So if you see, you remember, let me draw the, see, I have to always draw parallel plate capacitor, so I am drawing roughly, because if I go for the proper drawing then it will be not, or let me draw it properly only, no issue, I will draw. This is very hectic job, or let me use a scale. Drawing a parallel plate capacitor. Okay, so suppose this is my parallel plate capacitor, this is plus sigma and this is minus sigma, correct? So suppose this is how the charge is given to the surface, clear? Clear? And suppose the distance is d, area obviously a, everything is given, okay? So the question is how much energy is stored. If you remember, we have talked about something called energy density. What is energy density? Half epsilon naught into E square. That is the formula we have derived, correct? Can you tell me what is the, for this, if I want to calculate the energy, what is energy? Energy will be half epsilon naught E square into what? Volume. That will be my energy, correct? So let us put this value and calculate it. Half epsilon naught, what is the electric field? Electric field we have calculated, that is Q by A epsilon naught square, correct? That is the value we have know. What is volume? Volume will be A into D, correct? Volume will be A into D. So what you will get if you will cancel out everything, and that is half epsilon naught, correct? And this will cancel out A here, correct? And the numerator we will have a Q square, and one more thing is D. Now what is this epsilon naught A by D? If you bring D down, what is this? You can do like this, epsilon naught A by D. What is this thing? This thing is capacitance. So what is the energy stored? Energy stored we got is half Q square by C. And what is Q? If you remember, my capacitance is equal to Q by V. And what is Q then? Q is equal to CV. Just put it here. So what is the value you will get? Half CV square. So these are the very two important formulas for the energy stored in the capacitor. Energy. Remember, energy stored in parallel plate capacitor, not every capacitor. Parallel plate sorry, that is the energy stored in a parallel plate capacitor. This formula you have to remember every time. What is energy stored in a parallel plate capacitor? Half into C, Q square by C, or half CV square, or you can write one more formula, that is half. See, what is V? V is defined as a Q by C, or you can do one more thing, Q and C, C and V. Okay, I'll leave it. Like we can do one more thing, C and V is Q now, so half QV. That can be one more formula. If you want, you can write half QV. This can be also a one formula. Okay, like you can make, but these two are mostly used. Half QV, that can be also one formula. Clear? Till here, note it down. Clear? So I hope you understand the concept. For this question, if I ask you, can you calculate the what is energy will be stored? So suppose the potential is V. In this question only, if I ask you how much energy is stored, can you tell me what is the value? Half CV square, correct? So C, you know, put everything here, you would get epsilon naught pi r square by 2d into V square. That is the answer for this. If someone asks you energy stored in this question, you can solve. So this type of generally come for the NEET student. Okay, for NEET student they will ask you this type of questions. You will never get this type of question. Okay, but yeah, these things are important. So what we have covered in today's session, basically I have tried to build your concept that why we have to read capacitor, and we have started from very basic, that what is capacitor, how it is invented, for what need we need a capacitor, and then we have understand the concept of capacitor, and then we have understand about the spherical conductor, that how it act as a capacitor, but we have also understand what is the observation we have got from here, and then what are the requirement we need, and on the basis of that requirement the scientist has done some experiments, and what the experiment they got some results, and then they finally come to this conclusion, and we have invented something called as a parallel plate capacitor. For that parallel plate capacitor we have calculated the capacitance value, and after the calculation of capacitance value we have also calculated the energy which is going to be stored in the parallel plate capacitor. Clear? So this is what we have done. Now in the next session we are going to talk about how the capacitor is going to be charged, means it has to store some energy, but how that energy is going to be stored in it, who is going to provide this energy. Basically you are seeing that there is a charge is there, plus sigma minus sigma, how this charge is coming, who is providing this charge, that is the thing. So we will discuss about these things and we will continue our session. Till then, take care, goodbye, and if you like this session, please share it, like it and subscribe it. Have a nice day. Thank you.